Okay, we had our homework assignment on tangent and normal lines, and in the homework help video, I did problems numbers 2, 4, and 6. I want to do the remainder of the problem set here, and this is problem number 1. For questions 1 through 3, find the equation of the line A, tangent, and B, normal to the graph of f that is passing through the given variable. And here we have the point -3, 4, and just to verify that -3, 4, we need a point, first of all, to find either a tangent line or a normal line. And if we plug in, just to test, f of -3 in this function, we get -3 squared plus 2 times -3 plus 1, and -3 squared is going to be 9, so we have 9. 2 times -3 is -6, plus 1. Well, that does equal 4, so our point is indeed -3, 4. So that's verification. Now, let's derive f of x, and f prime of x is going to be 2x plus 2. And to find our tangent, our point of tangency, we need to plug in our x value from the point. So f prime of -3, this will give us our slope at this point, is 2 times -3 plus 2, which equals -6 plus 2 equals -4, and that will be our slope of the tangent line, m sub t. And so accordingly, our equation for the tangent line is going to be, using point slope form, y minus 4, which is y minus y sub 1, equals -4, which is m sub t, times x plus, or minus -3, which is going to be plus 3. So that's going to be a, so I'll just put a here, the equation of our tangent line. And our slope for our normal line is going to be the negative reciprocal. So m sub n, the negative reciprocal of -4, is going to be -1/4. So in every other respect, things are the same for this problem. So instead of the tangent line, our normal line is y minus 4 equals negative, oops, not negative, but positive. I made a mistake. See, it's going to be positive 1/4, negative reciprocal. So it will be 1/4. One thing, the signs are opposite. 1/4 times the quantity x plus 3. So that's part B. Okay, problem 2. We actually did this in the homework help, and just to go on and show that solution, I left it up here so you can pause and look at the solution for problem 2. Now we'll go on to problem 3, which we haven't worked out yet. And this time we're not given the point, so we need to find, passing through x equals 1 to the point, we need to find our, let's see, our point. Well, we know our x-coordinate is 1, and our y-coordinate is we're going to find out by putting f of 1, putting in 1, equals 1 plus 1 over x, which is 1 over 1, equals 1 plus 1 equals 2. So that's going to be our y value. Now to differentiate, to find the tangent, the normal, our f of x, we're going to rewrite as x plus x to the -1 power. 1 over x is x to the -1 power. So f prime of x equals 1 plus negative 1 times x to the negative 1 minus 2 minus 1 negative 4. So negative 2 power. So that is going to be equal to 1 minus 1 over x squared. And so now to find our tangent slope, we'll put f prime of 1 equals to 1 plus negative 1. Well, I'll just write it the way I had it earlier here. I'll say 1 minus 1 over 1 squared, which is going to be 1 minus 1 equals 0. So that is our slope. So to find our, this really should be right at the bottom here. So our point is going to be y minus, our tangent line, y minus 2 equals our slope, which is 0, times x minus 1. So that's just going to be the point y equals 2, right? Because this all zeroes out. So y minus 2 is equal to 0. And so y equals 2. That's going to be, that's what that is going to be. So our slope, if that's going to be m sub t. M sub n is going to be the negative reciprocal, and so we're going to have negative 1 over 0. Well, that's undefined. So being that so part A is y equals 2, and part B is there is not a tangent line, that's going to be undefined. Well, that's going to be actually an x equals going through that point. So that's going to be x equals 1. So that's going to be our tangent line, our normal line, tangent line. Okay, that's kind of a weird one. I'm going to check that out using the calculator later. Okay, 4. We did this already. This is 4 worked out, and so we'll look at that again. 5. Evaluate the limit as x approaches infinity of 5x to the negative x power plus 10 over 6e to the x power minus 1. What's happening here is we have two functions. In the numerator, this function here, 5e to the negative x, is going like this, down towards 0, and the one at the bottom is going up like this, toward infinity. And so it's like we have 0 over infinity as we go towards positive infinity. So our answer to this is going to be the horizontal asymptote, y equals 0. So this is our answer. The limit as x approaches infinity, 5e to the negative x power plus 10 over 6e to the x power minus 1. So that's that one. Problem 6. At what points on the graph of y equals 1 over x, the tangent line perpendicular? Well, I think we did this one in the homework help video. So we'll just go on to number 7. At x equals 1, find the equation of the normal line to y equals x squared minus 4x. So we need our point. So point is going to be 1. That's our x coordinate. Our y coordinate is going to be, we're going to put y of 1 equals 1 squared minus 4 times 1 equals 1 minus 4 equals negative 3. So negative 3 is our y coordinate. And we're going to find, let's see, let's find y prime. That's our next step. We have our point, we need our slope. So y prime equals 2x minus 4. And plug in 1 for x, y prime of 1 is equal to 2 times 1 minus 4, which equals negative 2. And so that's going to be m sub t. Well, the negative reciprocal is the normal line, the slope of the normal line. So it's the negative reciprocal is going to be 1/2. As we multiply 1/2 by negative 2 together, we get negative 1. And so the equation of our normal line is going to be y minus negative 3, which is plus 3, equals 1/2, and that's going to be x minus 1. So this is the equation of our normal line. Okay, now problem number 8. Find an equation of a line that's tangent to h of x equals 1 over square root of x and parallel to x plus 2y minus 6 equals 0. Let's go ahead and find the slope of this line that is parallel to the tangent line. To do that, we're going to solve this equation for y. So if we add 6 to both sides of the equation, plus 6 plus 6, we have x plus 2y equals 6. Now subtract x, we get 2y equals 6 minus x, and divided by 2, we get y equals, we have negative 1/2 x plus 3. So m sub t equals negative 1/2. Now let's go ahead and find h prime of x. First of all, h of x, we're going to rewrite this. You have 1 over the square root. Let me write this a little more neatly. 1 over the square root is going to be x to the negative 1/2 power. Now differentiating, h prime of x is going to equal negative 1/2 times x to the negative 1/2 minus 1, which is going to be negative 3/2. And so what that's going to be is negative 1 over 2 square root of x cubed. That's going to be h prime of x. And what we need to do is set m sub t equal to h prime of x, because that's where the slope will be. So we take this m sub t over here, and we have negative 1 over 2 square root of x cubed equals negative 1/2. Well, what we can do is cancel. If we just cancel everything, we can flip these upside down, cross multiply, however you want to do that. But what you'll have is essentially everything cancels out except square root of x cubed and 1. So we have the square root of x cubed is equal to 1. And squaring both sides, we get x cubed is equal to 1. We take the cube root of each side, and so x equals 1. So that is our point. Okay? I mean, that is our x value for our point. And what we do to find our y value for that point is we plug into this h of x formula, which is 1 over square root of x. So h of 1 is equal to 1 over square root of 1, which equals 1. So our point is 1, comma 1, and our m sub t is negative 1/2. So our point is going to be, our equation in point slope form is going to be y minus 1 equals negative 1/2 x minus 1. So that's going to be problem 8 worked out. I hope this video lesson has been helpful. Thanks for viewing.